Okay. Share content. Okay. So is this visible? So yesterday we have observed that there are three situations in which you will come across higher order systems. One is multi-capacity. Okay. Inherently second order system, and third is system with control system. Okay, so multi-capacity, it may be like interacting or non-interacting. Inherently second order system means it will like a F is equal to MA. Okay, so A is second order derivative. And system with controller means when we use a control system, that is the PI controller, that is the whole control loop. Then each component is like a process. So this will become in the series format, in the closed loop format. So combiningly, the overall may become more than one order. So it may be a second order system. Agree. Now today what we will do, we will see one derivation, how to derive the transfer function. So for the second order system, when we discuss the second order system, so already we have discussed about it, the multi-capacity systems. Multi-capacity systems means interacting or non-interacting systems. Okay, so now interacting or non-interacting systems. Multi-capacity systems, we have already proved that it is a higher order system. Okay, when the first order systems are arranged in the series fashion, like interacting or non-interacting, they will behave like a second order system. Okay, so the multi-capacity. Now we will move on the inherently second order nature of the system. Inherently second order system means when it will behave like a. Is this visible? This PPT?
Sir.
Yes, sir.
Okay. So transfer function for manometer, YouTube manometer, we will discuss here. Okay. Yesterday it was a little introduction of this. Now consider this is the YouTube manometer in which the working fluid, it may be a water or it may be a mercury. This shaded part is nothing but the liquid is occupying the space inside the YouTube manometer. YouTube manometer is generally the glass tube YouTube structure in which we use it to identify the what is the application of manometer?
Pressure measurement.
Pressure measurement, or we can identify the pressure and we can even identify the how much flow is in the pipe, yeah, like that. Everybody knows कि हम YouTube manometer जब pump pipe the flow to measure the flow, we can use the manometer also with the help of then all the equations like CD value and all these things, we can identify the flow, है ना?
Yes,
Okay, so now the today's concept is this clearly visible, this PDF?
Yes, sir.
Yes, sir.
Okay, so let's apply. See here, our aim is to derive the transfer function. So for this derivation, you have to identify what is output and what is input. Okay, because the transfer function, as you know, it is a ratio of Laplace of deviation variable, output deviation variable, Laplace of to the Laplace of input deviation variable. Okay, so what is output and what is input? You have to identify it first. Okay, the output, it means that it we have to develop a equation. We will develop the equation based on that things, which particular output is needed and which one will be changing, and based on that things, after changing in the input, how that output will behave. Okay, based on that information, you have to check whether which one is your input and which one is your output. So this is such type, this system is YouTube manometer in which the liquid will display. Okay, it will move, it will display. By what reason? Because of what reason? Because of P1 or because of delta P, that is P1 minus P2. The pressure differentials will make the flow of liquid from in one direction. Okay, so in this case, what is the input? The input is pressure change. Okay, and what will be the output because of that change in pressure? What will happen? That displacement make the movement of a liquid. Okay, the liquid in one limb it may get down, and liquid in the other limb will get raised. This is nothing but the displacement will happen because of the apply by if we impose the pressure. Agree? So some assumptions are there. Some assumptions means when we are applying the pressures deliberately or something because of the changes occurring to the flow or the pressure which is not under control, the certain forces come into the picture. Okay, so the first of all, identify the sign conventions. Sign conventions means the forces which are in the direction of the motion of the liquid. We will consider these forces as a positive forces, and the forces which will opposing, which are in the anti-direction of the motion of the motion of the liquid, that forces will be we will treat as a negative forces. Okay, so this is a very clear-cut system where the force is equal to ma equations we can implement. We can implement. Okay, we can implement F is equal to ma equation. Okay, so see here the situation of here. This is the diagram representing that okay, already there is some pressure on the leg one. Okay, because of that the displacement has been occurred, and because of that displacement the liquid will raise by some height. It is called as h in the leg 2. Okay, this t is equal to t and t is equal to 0 represent that in absence of pressure, at time t is equal to 0, system was at steady state. System was at steady state means all the forces and the mass of that liquid were resting here in absence of pressure. In this condition, the liquid, the height in the leg 1 and the height in the leg 2 by this particular liquid will resting on the center. Is this clear? So they will on the same plane in absence of pressure. Okay, so that particular we call it as a steady state. At time t is equal to 0, the liquid level at leg 2 was here, and the liquid head or the height in leg 1 it was here. Agree? But suddenly when the P1 is increases by some whatever the value it will be, because of that what will happen? It will display the liquid in the leg 1 downside. Similarly, the liquid in the leg 2 will displayed and the height will raised by the value h. Are you getting my point? ओके तो प्रेशर चेंज आने के कारण हाइट में वेरिएशंस आ रहे हैं. आर यू गेटिंग माय पॉइंट? किसके वजह से चेंजेस आ रहे हैं एच में? प्रेशर आने के कारण. ठीक है, तो आउटपुट क्या हो गया इसका? व्हाट विल बी द आउटपुट? व्हाट विल बी द आउटपुट? यस, H will be the output, and because of what it is changing, that will be the input. So what is the input? Pressure difference will be the input, correct. Therefore, so before we have to identify, we have to develop a dynamic equation which is representing such type of phenomena. Because of the pressure, that H will vary. So we have to balance. What we need to balance? Whether you will balance here the mass, whether you will balance here the heat, or whether you will balance here the force. Which particular option you will select? There will be the force. There should be the force balance we will use. So that's why the force balance, the Newton's law gives us F is equal to ma. Okay, F is equal to ma is nothing but force is equal to mass into acceleration. Okay, so number of forces are there. Number of forces are there. Okay, so some assumptions are there like that. Keep the air or any gas which is above the liquid in the same U2 having a very negligible density. ठीक है, क्योंकि प्रेशर जब वहां हम अप्लाई करेंगे तो प्रेशर के साथ जो एयर भी रहेगी या फिर कोई गैस रहेगी above the liquid height, above the liquid surface, it will get also compressed. So what we are considering, it is not contributing that much into this particular force, just to for the calculation. Okay, हमें इसे easy बनाना है to for the a simple, for the simple calculations we are considering that the density of that particular air or the gas is very negligible. Okay, next is the whatever the flow pattern of that liquid in the tube will be like laminar flow, not the turbulent flow. Okay, you heard about the laminar and the turbulent? Laminar flow and turbulent flow. Okay, so what we are considering here? We are considering here the flow will be laminar one. Flow will be laminar one. Agree? So what will happen? The motion will be a very smooth. It will not the turbulent one. Okay. So these are the some assumptions. Some more assumptions. Let me read out the assumptions. Assuming that the gas density is very small, then the density of the liquid and the flow of the fluid in the manometer is laminar under these conditions. The various forces are acting on the manometer fluid. The forces flowing in the direction of the flow of liquid are considered as positive, while the forces acting opposite to the motion of this particular liquid will be treated as a negative forces. Now let's balance. F is equal to ma will be there. Okay, so force, see these equations. Force due to pressure P1 on the leg 1. So number of forces are there. What are these forces? The very first force is force due to the pressure P1 on the leg 1. Okay, so because of the leg 1, P1 will be here. Minus force due to pressure P2 on the leg 2. Why this is the negative sign? Force due to pressure P1 on leg 1 is positive, but the force due to pressure P2 on the leg 2 is negative. Why? Because our assumption, the sign conventions represent that whatever the pressure opposite to the direction of the motion of the liquid will treat it as a negative, and P2 is pointing downward, but it is opposite to the motion of the liquid. Motion is moving from leg 1 to leg 2, and P2 is moving from leg 2 to leg 1. Therefore, it is considered as a negative. Is this okay? Is this fine? Okay. Now, next force is force due to liquid level difference in the two legs. So, it is just like a potential energy. है ना, कुछ लिक्विड ऊपर जा रहा है, हम कुछ चीजें लिफ्ट करते हैं, तो इट इज लाइक अ पोटेंशियल एनर्जी इट विल गेन, है ना. So because of that liquid, it is rising up to some height, and because of that energy or the force we have to consider during this particular force balance. So third force is force due to the liquid level difference in the two legs, and how where it will be pointing? It is pointing downward, and downward means it is opposite to the motion of liquid. Is this clear? Therefore, it is negative. Force due to liquid level difference. Okay, agree? Agree? Force due to liquid level difference in the two legs. Students, is this okay? ठीक है. Minus, again negative, means something is in direction of the flow of liquid. Force due to fluid friction. Fluid friction. Okay, there is a glass wall in which the fluid is moving. So there is a friction between the glass wall and the liquid. And that friction itself a resistance to flow. It will offer a resistance to flow. That means it is opposite to the direction of the flow of liquid. Therefore, it is negative. Force due to fluid friction. Is this okay? Okay. So these are the number of forces involved in the manometer. Now compare it with the product of mass into acceleration. Mass of liquid in the tube itself into acceleration. Okay. Now let's quantify it. So replace it by the our parameters. So force due to pressure P1 on the leg 1, we will represent it by P acting on the cross-sectional area A1. Okay, what is the force? Force is nothing but the pressure into area. Okay, what is force? Force is equal to pressure into area. Okay, so P1 is acting on A1. A1 is what? A1 is the cross-sectional area of leg 1. See here, A1 and A2 are the cross-sectional areas of legs 1 and 2 respectively. Okay, actually A1 is equal to A2 is equal to A होता है, because it is a uniform cross sectional area होता है. ठीक है, we will see later. Next is force due to P2. It will again same P2 into A2 minus rho G. Okay, GC is a correction. Okay, in the okay, it is a acceleration gravity. Okay, conversion constant. These are what we call the corrections or the conversion. So it is mgh, mass into gravity into h is a height to which it is raised. Mgh is nothing but potential energy. You heard now. Okay, so it is rho into g into a into 2h. Okay, it is mg, mass into gravity. ठीक है. Next, force due to fluid friction. Force due to fluid frictions. We will apply different assumptions on that, and we will calculate it. We can calculate it. Okay. Next is right part of the equal to signs. Okay, mass and the acceleration we will define here. Mass into again the conversion factor of gravity, acceleration gravity. Okay, acceleration due to gravity. And what is acceleration? Acceleration is nothing but the first derivative of velocity, small v. Okay, so the notations are P1, P2 are the pressures, A1, A2 are the cross-sectional areas, rho is the density, G is acceleration gravity, G is the conversion constant, M is mass liquid, rho AL. Okay, V is the average velocity of the liquid. Where is V? V is in the acceleration terminology. Okay, dV by dt. H is a deviation of the liquid. See here, students, small h is a itself a deviation. Deviation of liquid level from the initial plane of rest. हम फर्स्ट ऑर्डर सिस्टम में जो मेथोडोलॉजी यूज करते थे, हम क्या करते थे कि पहले वी यूज अनस्टेडी स्टेट कंडीशन, देन वी यूज स्टेडी स्टेट, हम उसको सब्ट्रैक्ट करते थे एंड द सब्ट्रैक्शन इक्वेशन हमें मिलता था, उसमें मिलता था हमें डेविएशन के लिए, है ना। बट इसमें क्या हो रहा है सेकंड ऑर्डर सिस्टम में, ऑलरेडी द एच विच वी आर रिप्रेजेंटिंग ओवर हियर, इट इज इटसेल्फ अ डेविएशन। आर यू गेटिंग माय पॉइंट? That h is itself a deviation. Are you getting my point? Okay. So further, when we implement force due to fluid friction, okay, and all the equations, laminar flow equations, fluid friction equations, okay, I will give you the in between the equations of that, but volumetric flow rate is a dh by dt, okay. A into average velocity. dh by dt is nothing but velocity. A into area into velocity. It will be like a pi r raised to the power 4 8 mu delta p by s. Okay, you can derive it. Don't derive it. Just write down delta hf, that equation delta hf rho ga. इस equation में अगर आप डालते हो तो you will get this equation. Okay, the force due to fluid frictions you will get like this. Force due to fluid friction is equal to delta p pi rho square by gc. अब इसमें थोड़ा क्या है कि इसमें नंबर ऑफ इक्वेशंस आपको डालना है कि फोर्स ड्यू टू फ्लूइड फ्रिक्शन एक्चुअली क्या है, इट इज अ डेल्टा एच एफ रो जी, डेल्टा एच एफ रो जी ए है। ओके, क्या है कि दिस इज नथिंग बट fluid friction. Okay, force due to friction, force due to friction, force due to friction is nothing but delta एच एफ रो जी ए। ठीक है, अब डेल्टा एच एफ रो जी है, ठीक है, इसको वन लीजिए। अब इसमें नीचे कुछ चीजें आपको सब्स्टिट्यूट करना है। डेल्टा एच एफ को हम करते हैं एल बाय आर, ओके, वी स्क्वायर बाय वाई जी वेलोसिटी। ठीक है, अब इक्वेशन 2 है। अब इसमें एफ कैसे डिफाइन करते हैं, एफ इज नथिंग बट 16 बाय आर ई। ठीक है, इसमें आर ई कैसे डिफाइन करते हैं, आर इज इक्वल, व्हाट इज आर इज, आर इज रेनॉल्ड्स नंबर du rho by mu, dv rho by mu। okay, so substitute all these equations in equation number 1। okay, so you will get this equation, so you will get this equation, a at mu l by r square gc dh by dt। okay, and so you at home you try to solve it and bring it like this। ठीक है, our question is not how to bring it in this particular format. Our aim is to develop the particular equation which will gives us the transfer function। okay, so v is nothing but dh by dt, dv is equal to 2h by dt square, all these things when we substitute over here in the force balance equations, so delta p, a1 is equal to a2 is equal to a अगर हम लेते हैं तो p1 by p2 is equal to delta 2, p1 minus p2 will be delta p, okay, into a minus force due to its, see, p1 and p2, p1 minus p2 into A, P1 minus P2 into A1 and A2 are equal, it is A. Okay, this third terminology force due to liquid level difference. So force due to liquid level. This fourth terminology is nothing but the force due to fluid friction at mu L. See here is equal to mass is nothing but rho Al upon Gc, and what is dh by dt? That is the v acceleration. Acceleration is d2h by dt square. So this equation represent that key U2 manometer is second order system. Why? Because its equation which representing its dynamic behavior is of second order differential equation. Therefore, it is a second order system. Agree? Rearrange it into the standard format. So L by twice G d2h by dt square plus 4 mu L by rho G r square dh by dt plus h is equal to Gc by 2 rho G. Delta P will be the equation. So in this, just like this one, see here, you represent in this format and you can define the natural period will be this, 2z tau will be this, and kp steady state will be this. Okay, rearrange it. इसका कोएफिशिएंट 1 होना चाहिए. A0 is not equal to 0. Remember. ठीक है, y का कोएफिशिएंट 1 होना चाहिए. y is nothing but h in this case. y क्या है हमारा? h है, आउटपुट है. ठीक है, ft क्या है हमारा? डेल्टा p है. See here. So they have arranged it in this fashion. Delta p is my ft, h is my y. Okay, so tau square d2h by dt square plus 2 z tau th by dt plus h is equal to kp delta p. Agree? Then take the Laplace transform of this, because I want Laplace transform. Laplace transform will give us such type of equation. H by delta p is equal to kp by tau square s square plus 2 z tau s plus 1. Are you getting my point? ठीक है? So this will be the transfer function of U2 manometer. This will be the transfer function of U2 manometer. Agree? Students? So this is little different than that of the first order system, because H is itself one of the deviation we are treating here. Okay, so this is the general form of our first order system, second order system. Okay, so the next question is homework for you. I have already derived it. Transfer function for damped oscillator. Damped oscillator. Damped oscillator एक ऐसा situation है जहाँ रेल के बोगीज को रोका जाता है. We can say that the spring is there. Okay, the dashpot C is there. The weight W is over here on the wheels. Okay, the FT is pulling it on the right hand side. ठीक है, तो इसका mass balance क्या होगा? F is equal to will be like this: force due to spring, force due to friction in the dashpot, plus so this is a example which you need you try at home. ठीक है, न्यूटन्स लॉ ऑफ मोशन आपको इंप्लीमेंट करना है. Net force acting on the box is equal to rate of change of momentum. Force is equal to m into a. ठीक है, देख लीजिए इसको. ठीक है, एग्री? देखो मैंने यहाँ सब पॉजिटिव लिखा है, बट यहाँ साइन सिग्नि देखो, दिस इज नेगेटिव, दिस वन इज आल्सो नेगेटिव. Why? Because spring will oppose. Similarly, friction will oppose the motion. Okay, plus driving force, and it is the acceleration due to gravity, mass into moment. That is the momentum terminology. Rate of change of moment. ठीक है? So it will be like equation 3 there, and by arranging all these terminologies in the standard format. What was the tau square? Tau square is a m by k, 2 zeta c by k, and xt will be ft by k. Okay, so likewise, you have to derive it. So we'll stop here today. This was the example of a second order system, but more examples we will discuss later. Do you want anything or any question regarding this? I will